Humanity spends billions of dollars every single year on various space programs and space exploration. In 2023 alone, NASA spent a whopping $25.4 billion, dollars, and the world as a whole spent over $117 billion dollars on space programs and the like, which, if stacked as $100 bills on top of each other, would be approximately the height of Mount Everest, plus an additional 3,000 meters. Needless to say, that's a lot of money. But where does it all go? It turns out that space missions are expensive. The Apollo program alone cost $257 billion dollars adjusted for inflation. The Curiosity project, the Mars rover, cost $2.5 billion dollars to send, and that's just one of the Mars missions. And these projects quickly add up. The International Space Station has cost over $150 billion dollars and costs roughly an additional $4 billion dollars per year to maintain. Spending is large in terms of the private sector, too. Last year, Elon Musk's SpaceX has spent over $3.1 billion dollars on its various projects, and Jeff Bezos has poured over $200 billion dollars into his own space company, Blue Origin, in a 20-year period. After spending all this money, what do we have to show for it? Not much, it seems, on the surface. Some satellites and some cool black hole photos. No moon settlements, and the Mars landing keeps getting delayed more and more. Or is that the full picture? What does humanity gain from space exploration, and should we keep doing it? Firstly, let's talk about the benefits of space programs. Number one, and most obvious advantage of going to space, is technological innovation. Various everyday technologies that make our lives better, everything from freeze dried food and water purification systems to cordless tools and phone cameras, were developed initially for our adventures in space. The development of these technologies would have likely been slowed down significantly had they not been needed here. Those same space adventures created hundreds of thousands of jobs that otherwise wouldn't exist, and most of them are extremely highly paid engineering, physicist, scientist, and IT specialist positions. High skilled jobs benefit humanity as a whole, not only because of what these people do while working for NASA, SpaceX, or any other space organization, but also because of the experience they earn while working there, which helps them innovate more in other fields and companies once they leave the field of space exploration. Now, looking at benefits which are a bit further off into the future, space exploration offers lots of commercial opportunities, such as space tourism, asteroid mining, and various other resources. Technology invented for space travel and exploration will also undoubtedly come in handy if there's ever a need to break up large asteroids heading towards Earth, or even when settling other celestial bodies in case of such a disaster being unavoidable, though that currently belongs more in the category of science fiction. In terms of disadvantages, the biggest one has to be opportunity cost. The cost of space exploration is not only the aforementioned hundreds of billions of dollars, but also the loss of everything else that could have been done with those billions of dollars had they not been spent on space exploration. Those dollars could have been spent on fixing other burning issues that are of high importance in the public conscience, such as world hunger, homelessness, or climate change. The fact that those issues cannot be solved by simply throwing money onto them is a topic for another day, but I digress. The money could have been spent in many other ways, the simplest of which would have been lowering national spending and deficits of various countries investing in space exploration, namely the United States of America, which has a burning debt problem. There are also various environmental concerns, the simplest of which are the added emissions of CO2 and other greenhouse gases coming from rocket and satellite launches and fuel usage. The other, less obvious concern is that of orbital debris. Derelict spacecraft and upper stages of launch vehicles, carriers for multiple payloads, objects intentionally released during spacecraft separation from its launch vehicle or during mission operations, junk created as a result of spacecraft or upper stage explosions or collisions, solid rocket motor effluents, and tiny flecks of paint released by thermal stress or small particle impacts are all considered orbital debris. So far, more than 25,000 objects larger than 10 centimeters are known to exist in the atmosphere. The estimated population of particles between 1 and 10 centimeters in diameter is approximately 500,000. The number of particles larger than 1 millimeter exceeds 100 million. As of January 2022, the amount of material orbiting the Earth exceeded 9,000 metric tons. That seems small on the surface, but these objects create certain issues for further launches, exploration of space, and existing satellites. When satellites, some of which travel as fast as 30,000 kilometers per hour, hit one of these objects, they can easily get destroyed. They can cause problems for rockets as well. Luckily, right now, the amount of debris is not quite large enough to cause major problems for us, but the danger is that we might reach a point where there are so many debris from past launches and satellites that launching new rockets becomes impossible, thus locking humanity on Earth permanently. With a simplistic cost benefit analysis of space exploration out of the way, let's now take a look at what roles the public and private sectors play in this industry. The two are quite different in their advantages and disadvantages and what they are good at. Let's start with the public sector. This is where humanity's space adventures started. Originally, space was a military front. Satellites were developed and launched by both the United States and the Soviet Union with the goal of gaining military high ground and to gain a communication advantage on each other. Whichever country had more firepower in space could threaten the other with weapons and missiles which they couldn't deflect, or at least that was the idea. The space race began as more of a show of prestige and as a way for both of the rival superpowers to project their power onto the rest of the world. The advantage of the public sector is its ability to fund and pursue goals that are not constrained by the profit motive alone. A government may pass enormous funding for a project that wouldn't naturally spring up in the private sector, at least not initially. On the flip side, this exact ability also often causes unsuccessful public projects to lose far more money and fail far harder than they would if they were funded by the private sector, who would discontinue them as soon as they proved futile. Public projects are often far less efficient with the funds they are granted compared to privately funded ones, because they aren't under the pressure of being profitable or losing funding. This is the biggest advantage of the private sector, its cost effectiveness. The private sector is under immense pressure to get their money's worth, and that is true in any industry, including space exploration. If a company in the private sector fails to make the expected profit, they are likely to lose their funding as investors choose to pull their funds and invest them into other ventures with higher profit margins. And this pressure has really been there in the space industry, since its nature requires lots of funding and many employees. During the 1960s, NASA's launch costs were as much as $100,000 per kilogram of weight launched into space. After pioneering industry innovations, the cost was reduced significantly but remained stable for decades, from $16,000 to $30,000 per kilogram of weight launched, which is still extremely expensive. Only in the 2010s, when privately developed launch systems emerged that were forced to lower costs or go bankrupt, did costs lower again. This started a sort of price race to see who could deliver the best service with the smallest cost. The results were surprisingly positive. SpaceX pioneered lower launch costs with Falcon 9 in 2010, which cost $2,500 per kilogram, and then with Falcon Heavy in 2018, which cost $1,500, 11 times lower than the average launch cost from 1970 to 2010. This is thanks to some groundbreaking innovations, such as lower fuel usage and namely reusable rockets. Elon Musk has set a goal of achieving a launch cost of only $10 per kilogram for Starship, which would be amazing for space travel, but considering Musk's history of overpromising and failed to reach goals, shouldn't be taken too seriously, at least for now. Nonetheless, space launches are radically cheaper than they used to be just 10 or 20 years ago, and are becoming even cheaper as time passes. Citigroup, an investment banking company invested in the process, expects that launch costs could fall to as little as $30 per kilogram by 2040, while in the bear case scenario, they'd fall to $300 per kilogram, which is still an amazing reduction. Another recent innovation is that we can also get into space by using helium balloons to launch ourselves or payload. This is how even you can get into space for the low price of $125,000 in 2024. Well, maybe not a low price, but certainly much lower than the average person thinks would cost to go to space. With costs as low as this, space tourism, moon bases, and even Mars landings start to leave the field of science fiction and enter into reality. And if the costs keep decreasing as projected, in 50 years, space travel could even become attainable for the average Joe. This all leads us to the conclusion that the private sector is much more efficient and innovative than the public sector. There is at least one major problem which the private sector is unlikely to solve on its own: the already mentioned orbit debris field around Earth. Similar to problems such as air pollution, the private sector runs into a pitfall of nobody really caring about the pollution that isn't happening on their land. Since nobody owns air, nobody really cares to protect it. And similarly, since nobody owns the Earth's orbit, nobody is likely to care that it is being filled with junk and debris. And the only situation in which they are likely to care is considering whether their own rocket can or cannot launch because of it. The solution, though, is likely similar to the solution for air pollution and water pollution: general legislation meant to lessen it. This could be in the form of mandates for rockets that don't leave parts floating in the atmosphere, or cleanup mandates, or any number of other approaches. I don't know the specifics. I am not a space engineer, only an economics student, but I am sure it can be done. In my humble opinion, the best way to go about exploring space in the fastest and most economical way is through the public and private sectors working together. While the private sector may be more efficient when it comes to actually doing the dirty work itself compared to the public sector has the power of legislation, which can be used to boost the private sector's efficiency even further. The most obvious way to do this is guaranteeing patent and property rights. Patent rights foster innovation by themselves, since if the would-be innovator is unsure whether it be worth it to spend millions or even billions of dollars on new innovation, only to have it stolen by their competition, he might consider just waiting around for someone else to invent and then copy that inventor. And so nothing ever gets done. And so when we guarantee patent rights, we enable the would-be innovators in our society to do just that: innovate and be rewarded for their innovations with profit, and making sure their innovations aren't stolen right away. Property rights work similarly. They can encourage exploration and investment. If the government, let's say, seized the moon as United Nations property and then sold plots of it as private property, wealthy individuals would buy it for various economic, prestige, or other interests. These new buyers would then put economic pressure on space companies to make getting to the moon even cheaper, to invent new ways of dealing with hostile conditions such as the radiation and the lack of an atmosphere, and eventually to develop infrastructure so their new property can even be used in the first place. Many would examine different economic interests on the moon and come up with ways of making money, perhaps by harvesting iron, titanium, or uranium found on the moon, or by generating solar power in a place with no clouds. And suddenly, you have industry on the moon. To make a profit, these wealthy individuals and companies would be forced to find even cheaper ways to transport people, goods, and facilities to the moon. And suddenly, we have some moon colonies. After the first workers get on the moon to mine titanium or whatever it is they end up doing, this will cause a need for other services for those same workers. And if there are enough workers, other businesses will pop up to serve their needs. And then, with a little time, boom, a moon society. And this would all happen as a result of legislation. Literally pieces of paper guaranteeing private property and patent rights without the government and taxpayers having to spend much or even any money at all. If we do colonize the moon, this is likely how it is most likely to occur: by converging economic interests and not by pioneering astronauts going to live there just for the sake of living there and springing up a society. A historic example would be the American push westward. To populate the vast lands west of the Appalachian Mountains, the United States sold tons of land and guaranteed property rights to the settlers who ventured out onto the frontier. At one point, the government even passed the Homestead Act, which granted settlers up to 160 acres of land for $1.25 per acre, provided they live on it. And wouldn't you guess it, with policies like that, the Americans very quickly populated the West, much to the detriment of the natives, pushing out other nations such as British Canada and Mexico based on population alone. Luckily, there are no natives on the moon, or other celestial bodies, at least that we know of, which means that space really is free real estate. The only thing we ought to do is pass the right legislation and let humans do the rest. After all, we are extremely adventurous, brave, and greedy, which will all work in our favor when it comes to space exploration. And in the end, even though it doesn't seem like humanity is doing anything really exciting in space right now, we are making major progress, and we aren't wasting too much money. Space travel is getting cheaper and cheaper to obtain, and might soon even be attainable for the average among us. And then, who knows what awaits us? If you learned something new from this video, make sure to subscribe and let me know your thoughts down below. Do you agree with me, or do you perhaps offer a different interpretation of the topic? I would love to hear from you, and maybe we can even argue in the comments.